what does this mean, visiting the source? I wanted to take a moment before we dive into CPython and all the internals of Python to just go ahead and talk about all the ways that we can deal with problems when we're programming. When you don't know how to do something programmatically, or when you encounter an error message, you have a couple options. You could, go on search on Stack Overflow and just copy and paste something from there, try and rerun it. And that's probably the most common kind of development loop we see with Python programmers. We don't really have a issue with rerunning code. We don't have to wait for that really long compile time that you see in more conservative, truly compiled language. But this doesn't always work because the thing I copied in from Stack Overflow might be Python 2. It might not work for Python 3, or I just simply, might have the wrong code snippet and I don't know what it does or how it should fit into my code. I could go ahead and complain on Twitter alternatively, but, I love answering questions on Stack Overflow. I don't really like answering questions on Twitter. It's not really the place for that in my opinion. So whenever I see people tag, hey, @BigProject, I have this issue, and then the Twitter handler is nice enough to try and help them debug that problem, it's just not the place for it. So maybe instead we create a new GitHub issue. And now this issue, you have to figure out if this is a bug or not. Was it my fault, or is it the library's fault? Is it the code's fault? And sometimes we might not know that, right? It's okay to be working with libraries who you don't know how specifically they work, but you can use it quite well. After that, I would suggest, if I don't want to open a GitHub issue, if I don't want to complain on Twitter, and if I can't find anything on Stack Overflow that's relevant, maybe I read the documentation. And this usually works, right? You can usually find things on the documentation, but what if there is none? Or what if the documentation is sparse? Well, I guess we just give up and that's the end of that, right? Not really. The final step, the main solution in my opinion, is to visit the source code. A lot of times the source code will have documents or comments in it that you can use for your own reference, and if not, hopefully the source code is well written such that you can read through it yourself and try and figure out what the source code is attempting to do, why you're hitting this weird error, or how to include some feature that they used in the library into your own code. And I want to give you an example of a time that I did this. I've been doing a lot of work with matplotlib and generating visualizations recently, and I came across not an issue, but a feature that I wanted to implement. I wanted to very specifically stack text in a vertical way, such that I was limited by the axes.txt, or the generating my own text elements would not cut it. I wanted to stack it almost exactly how you would see text in the legend of a matplotlib plot. And so what I wanted to do here, I was thinking, well, where have I seen vertically stacked text in matplotlib? I've seen it before, and as I mentioned, it's in that legend. And how would I go about reasoning about it? I've looked through the documentation of matplotlib. They say never to really instantiate legends all on your own, just use the convenience methods that they offer. But what if I want to dig into the legend, figure out how they implemented something, and then pull it back out and use it in my own code? Well, we can start by always visiting the source code. And to do that, I just need to either Google what their GitHub is and visit their GitHub, or I can find my local installation, figure out the path, print out the file. And if I go ahead, I can take this file path, copy it here, and I can open up for my own use. And specifically, we'll go ahead and let's figure out what file might I be interested in. If I'm looking for something called legend, just a quick scan through here, I am willing to bet legend.py. Sounds like a very good starting place for me, so I'll go ahead and open up legend.py. You can see the legend modules defines a legend class. Okay, I'm not interested in creating my own entire legend. I just want to find out how do they vertically stack those labels. So let's look for the legend class, and I can just do that just by searching through here. There we go. So the legend inherits from an artist. That's also good to know. And we'll go ahead and we see they init here and labels. That's what I'm looking for. I want to figure out how to vertically stack text just like matplotlib does in a legend. So now let's go ahead and look for labels, and we can just kind of follow it through here. Labels is a list of strings. That's fine. I don't care about label spacing. Trim handles and labels if it's an illegal label. It just looks like they're cleaning up some of this here, right? It's just kind of like a filter, and if not, we just append the original label. So I'm not really interested in that. Let's keep going, keep perusing. I see this self.init legend box. Okay, that might be of interest. It turns out that that's the next step here. We start this empty list of handles and labels. That might be of interest here, so I'll kind of mentally note that. Okay, for the original handle and a label in our zipped legend handles and labels, looks like they are iterating over all of the legend artists and the labels at the same time to pair them together, just like you would see in a legend. And then we come down here. If the handler is none, okay, they don't really like that. If the handler is not none, meaning we have, I guess, a valid entry. Okay, this is interesting. I see a text box. They create a text area and then a drawing area. And I've seen legends, right? The text is usually on the left, and then the little, image or artist is usually on the right. So keep that in mind. And it looks like they append that to something, to a list that they call handles and labels. And if we have handles and labels and calls and rows, now I don't think I care about this because I'm not here to figure out, how to orient columns and rows. I'm just here to figure out what are they doing with these labels. And so they store it in this handles and labels box. And so maybe I need to search for that. Oh, I see handles and labels right here. And it looks like they're putting them into an object called an hpacker. And they're giving the hpacker a list of children, which is an H and T, which is a handle, and I'm assuming a text. So it probably corresponds exactly to what we saw above with this handles and labels list, where it was a handle box and a text box, which is what matplotlib calls a drawing area and a text area. And just like that, I'm kind of able to just parse apart how does matplotlib go about creating a legend? What is it using under the hood? What objects? And what data structures is it using? And if I go here, I'll search for text area because this definitely sounds like something I'm interested in. Start searching from the top. Maybe we can find the import. And I see, okay, so we have a text area, we have a drawing area, vpacker, hpacker. That looks like everything that I am interested in. And the hpacker and vpacker, so I'll go ahead and I'll grab all of these and just pop them into my work. But I do need one more thing. I need to, well, what do they do with the vpacker? Where do they actually add it to the hpacker, I should say. Where do they actually add it? Well, let's keep moving it. Oh, that comment actually seemed quite useful. A legend box is a hpacker, horizontally packed with columns. Each column is a vpacker, vertically packed with legend items. Okay, so it looks like the hpacker and vpacker are some kind of just organizational components, and they can have one or more children that they oversee, and I can reason about this legend layout now. It's a vertical packer that has horizontal packers that have two components, a text area and a draw area. So if I want to abstract this out and use it for my own purposes, I can use a vertical packer and just supply it with two text areas. That sounds reasonable. So each legend item, okay. Offset.text area, the label box, okay. But missing that last piece that I'm looking for. So we find the area where we actually add the packers into the legend. I see I'm back here at item boxes. Legend handle box doesn't seem too interesting. This seems like the area around it. And I'm sure somewhere we have to add it to the figure, but we can go about that in just a moment. I want to try playing around with this hpacker and vpacker idea, the stuff that I just pulled out of matplotlib. And so to do that, I'll start by instantiating my own figure that I can draw on. So we'll just go ahead and get rid of that old import. And we'll grab our own figure, and we'll just start here. And text area, so my text will be a text area. And let's go ahead, maybe I'll actually import subplots instead of just a figure. We'll keep it as figure for now. And so I can instantiate a text area, and let's just see if this runs. Okay, so text area is missing one required positional argument. And the nice thing is text area is actually documented. And so I know it's the same thing as matplotlib's text. S is actually the text that you want to add, and it also takes some coordinates. And I'll give that another run, see if it works. It got multiple values for S, so maybe S comes first in this case. And we'll go ahead and do that. And this might not take coordinates. Okay, so it looks like we've properly defined our text area. At least we're not, hitting any issues here. Can we add that? And then can we show? Now this is always the question with matplotlib. We can add things to our figures, but will they actually show up? In this case, it doesn't look like they showed up. So we need to maybe add just a little bit more. Maybe we do need that vpacker idea. And just taking this from how this worked in the legend, I know that I am aware that the vpacker takes multiple children. And so that has to be a list. And we'll go ahead. Oops, I meant to add the packer now. Now we're adding kind of like a wrapper around this text area. Let's see if this pops up. Oh man. Unsupported operand types for none and float, just because I wrapped this in a vpacker. So let's go ahead and let's extract this, go back to a step that we know worked. All right, just take it back one step, and we can actually see, just by adding that text area to our figure, we get this little text all the way down here. I'll go ahead and I'll make that even larger for you so everyone can see it very easily. Change the default font size there, and we see this is a title. It's just all the way down in the bottom left. But how do we reason about getting this vpacker to work? I tried to get it to work, and I got an error. Well, like any good programmer, I should read that error message and try and reason about it. None and floats, and let's take a look at the line in question. So pad equals self.pad times DPI. So to me that says it's trying to figure out where to place this text area. And for some reason, I can tell that none type is on the left, floats on the right? Some reason self.pad is none, and then DPI is on the right-hand side here. And so what we see here is I might need to take one more dive back into this source code here, and let's go ahead and we'll open this up as well. And let's look for self.pad. Okay, so self.pad it's the pad from init, and that's got supered in, and this looks like the line in question that I got an error on. So for some reason, all I know is that self.pad is none. So we find our vpacker, it inherits from vpacker base, so let's look at vpacker base. This inherits from offset box. There we go. And it looks like, okay, init takes pad equals none and sep equals none. So this could very well be the source of my issue. If we're just passing those in as none, and matplotlib is expecting them, as the documentation says, to be a float, maybe I just need to pass those arguments in. So let's give that a go. Okay, and so with that all set up, give this a go. Oh, we see our title is nicely rendered, and we will never know if this works unless we actually add 2 text areas in, maybe a little bit longer, and we'll add text 2 and text 1. There we go. And so we see we get this as a title, and maybe we just need to place this somewhere specific. How do we go about doing that? Well, looking through a little bit more matplotlib, you'll note that when they create their legend, they insert the vpacker into yet another object, into this anchored offset box. And so I'll just need to wrap that one more time. And this also inherits from the same area. So it takes a child, that's the packer. And then now let's go ahead and try adding this box. Anchored offset box. We have a typo here, right there. Okay, it requires a positional argument lock. Oh, that's just like what the legend takes, right? That center, upper left, upper right. Has no attribute bbox. Oh man. So we have to also pass it just a couple more arguments here. And we see that I've moved that box. There's a frame around it. Let's just go ahead and center this. And we do that with our transform parameters. And I named my figure F. And so you can see I've moved my title. Let's actually try and center this into the middle of our screen here instead of on the top right, top left. But here you can see I've created a title, I've created a box around that title, and I can align these in any direction that I want just using some characteristics of the packer itself. And I can actually turn this frame off as well. But here you can see that there was no documentation for this. There's no examples on their documentation site. However, in the source code, if you can figure out what it is you want to do and reason about, well, where might this already have been done? I'm able to dig through the source code and I'm able to find an existing solution for a problem that I have. Sometimes these libraries don't expose the very explicit control over things that we want to do, and we need to kind of disassemble how they work in order to do the things that we want to do with them. And so whenever you need to vertically, horizontally stack some text left, right, top, bottom, we know that we can reach into these objects. But let's take one very large step back. Did you notice that I just did something that most people find extremely complex with matplotlib? Just by looking at the source code, I didn't have to mess around with the documentations. Am I on the latest version? Am I on 3.5? Is this 3.4? Does this match the one that I installed? It doesn't matter when you search through the source that's installed on your machine, right? I always have the same version that I'm using. I could go into that source code. I can put print statements or print functions. I could log things. I can figure out how it works and rerun it, re-execute my code, and I would actually see the changes that I made to that source code. And that is one of the powerful things that you can do in Python. You have full access to the raw source code, to the human-readable raw source code. It's not some pre-compiled binary that you can't interact with. And this is exactly why that we deploy Python files the way that they are. They're deployed as .py files on disk because you're supposed to go and read them. And that is the whole point. The point of this is to look at the source code. Don't be scared of the source code, of libraries that you're working with, of Python itself. Whenever you encounter an issue and you can't figure it out from online resources, from documentation, you can always visit the source.